problem 25, and this one is says let u equals to 1 plus x cubed divided by 3 factorial plus x to the 6 divided by 6 factorial plus x to the 9 divided by 9 factorial plus dot dot dot. And then we're asked to then we're given v equals x plus x4 to the divided by 4 factorial plus x7 divided by 7 factorial plus x10 divided by 10 factorial plus dot dot dot. And then w starts with x squared right here, x squared divided by 2 factorial plus x5 divided by 5 factorial plus x8 divided by 8 factorial, etc. And if you take a look at this pattern here, if I take the derivative of w, we get v. So this 2 goes down, and then the factorial gets out, we lose a power. And if I take a derivative of v, we get u. So we can then show that they're related by integrals and derivatives. So, and also we're asked to show, so that's what we're given. Then we're asked to show that u to the power of 3 plus v to the power of 3 plus w to the power of 3, and then subtract by 3 times u times w times v equals 1. So in other words, so we can actually do implicit differentiation here, and then also take derivative of this and make them all related and throw that in there. So that is what it looks like we should be doing. Alright, so now let's take a look at the solution. And again, so we're going to be taking derivatives of this and then do implicit differentiation here. But first, before we do that, we need to be able to, we'll show that we can take derivatives. So let's first use the ratio test, which is a pretty smart way of determining that it is convergent for all values of x there, to show that the series for u, v, and w have positive radii of convergence, i.e., I believe what they're saying is r is greater than 0. So it's not, r is not equal to 0. Otherwise, that would be convergent only at one point, at the power series x equals a. So that we can do term by term differentiation. And let's just take a look here. So here's a ratio test. Recall from my earlier video. If so, we have 3 cases. If the limit n, the limit as n approaches infinity of an plus 1 divided by an is equal to L, which is less than 1, then the series summation from n equals 1 to infinity of an is absolutely convergent and therefore convergent. If that limit is instead equals to L, and this is L is greater than 1, or the limit goes to infinity, then the series is divergent. If, however, the third one is if this equals to 1, the ratio test is inconclusive. That is, no conclusion could be drawn about the convergence or divergence of the summation of an, or the series an. Alright, so let's start off with u, and let's write this here. So in our case, we have, let's write a line like here. So u equals to 1 plus x cubed divided by 3 factorial plus x to the 5, actually to the 6. Let's go back up here. So this is x to the 3, then the 6, 9, etc. So it's separated by 3. This is going to be x6 divided by 6 factorial plus the next one x to the 9 divided by 9 factorial plus dot dot dot, etc. And here's remove that line, let's put this line here. So then we have here, and this goes all the way to the last one is going to be, well, this is a factor of 3, so these are going to be x to the 3n. When n is 0, it's 1. And well, when n is 0, the whole thing goes to 1, and this is divided by 3n factorial. And yeah, so when n is 1, we'll have 3 times 1 is just 3, and then 3 times 1 is just 3. When n is 2, we'll have 3 times 2 is 6, and the bottom is, 3 times 2 is 6. Factorial. Like this. So let's take the limit. Limit as n approaches infinity of an plus 1 over an, the absolute value of this limit. Alright, so this right here, let's fix that up. Alright, this equals to the limit as n approaches infinity, and let's plug that inside. So we're going to have absolute value of, and then we're going to have x to the 3n plus 1. So then plus 1 times 3n, times 3. It's just going to be 3. Whoops, get rid of that 1 there. 3 right there. Because if this is n is n plus 1, so 3 times n plus 3 times 3 times 1. So then it'd be 3n plus 3 all over the bottom is 3n times n plus 1. 3 times n plus 1 is just 3n plus 3 factorial. So that's this. And then we're going to be dividing by, in other words, we're going to have this on the opposite side. So we're going to divide by an. All right, let's just write this here. And then the an will be at the bottom. Will be, this is just x to the 3n. And then divided by 3n factorial. 3n factorial. All right, just put absolute value sign there. All right, so now we have this. And notice there's a 3n here minus 3n. So this just becomes x to the 3. So this equals to limit as n approaches infinity of, and now we'll have an x to the 3. And also there's a 3n factorial. I'm going to go x to the 3 times it by 3n factorial. But now this 3n plus 3 factorial is the same thing as writing, well, 3n plus 3 times it by 3n plus 2 and times it by 3n plus 1 and then times it by just 3n factorial. Like that. So we do all that and this just cancels out with this. Yeah, so then the n cancels out there. So all we're left with is this 3n plus 3, 3n plus n plus 2, etc., 3n plus 1. In other words, this whole thing at the bottom goes to 1 over infinity. So you're going to be dividing x3, whatever x is, divided by infinity. So for all values of x, doesn't matter. This is going to be approaching 0. Doesn't matter what x is, this is going to approach 0 there. So in other words, this limit is equal to 0. And I'll box this in, which is less than 1 for all x. Doesn't matter what x is. For all x. So, yeah, so it's for all x. In other words, this is less than 1. So it's equal to L, less than 1. Then this is absolutely convergent and therefore convergent for all x. So we could write converges for all x. So, yeah, converges for all x. And this is our u. And I'll just put it down like here. So u, so u converges for all x. Remember this whole thing was u, and we didn't limit the ratio test for this u there. And if we do that for the other ones, it'll be the exact same thing. All right. So u converges for all x. All right, so it converges for all x, and similarly, the ratio test converges for all, for v and w for all x. Or I just reworded it to be a bit more grammatically correct. So similarly, the ratio test shows that v and w also converge for all x, because the other ones can be doing the exact same thing. So v is this right here, and then you're going to have pretty much the exact same thing. All you're doing is changing this power. Instead of x to the 3n, you're going to have a slightly different. And they're all going to just cancel out because they're pretty much identical in form, just at different powers and factorials by number only. So thus we can now differentiate each of these series, or each of the series. All right. So what we'll do is we could do term by term differentiation. So let's write u again. U equals to 1 plus x cubed over 3 factorial. Remember, it's factor of 3 everything. All right, this becomes like that. Plus x to the 6. X to the 6 over 6 factorial plus x to the 9. 9 factorial plus dot dot dot. And now du. So du over dx, take the derivative, equals to, well, the first one's going to be 0. The next one's going to be 3 goes down, and we remove a power. There's a 3 factorial. Like that. All right, just put a factorial there. And the next one is plus, put the 6 down. 6x to the 5, and this is going to be 6 factorial. Plus the 9 goes down. X to the 8, subtract 1. Now we have 9 factorial plus dot dot dot. And then what happens is, well, this cancels with this, we're left with a 2 factorial and so on. Do that with all of the others. So this becomes just x squared over 2 factorial plus the next one is, well, similarly, yeah, you're going to have this cancels with this, 5 factorial. This becomes x to the 5 over 5 factorial plus the next one, this cancels with this, 8 factorial. This becomes x to the 8 over 8 factorial. Then plus dot dot dot. Now if we scroll up to our setup here, so if we go all the way back here, right here, so u is this, and then derivative becomes x squared. So this becomes w. So the number is x squared. So this x cubed, this one goes to 0, this x cubed goes down, subtract the power, get x squared. Then we have this, x squared over 2, and then 2 factorial. Yeah, so there's an x8, 8 factorial, and so on. So it's exactly that. So this is equals to w. This equals to w there. All right, so that's w. So now we can just take the derivative of this one here. So that's w. I'm going to move this down here. And so we're going to do dw over dx. And instead of writing it down again, well, we have it already here. So dw over dx is equal to, bring that 2 down, be 2 over 2 factorial times x to the 1. Then plus 5x4 over 5 factorial plus x to the 7. I bring the 8 down. 8 over 8 factorial, and then this is x to the 7, and then plus dot dot dot. So in other words, this becomes x to the 1. Those 2 factorial cancels, and then we're left with here is going to be x to the 4 over 4 factorial. You have a bunch of cancellations there, like this. Then plus x to the 7 over 7 factorial plus dot dot dot. And now let's take a look at what this one is. So the dw over dx, that's x, and then x to the 4, then we have x to the 7. So that's equals to v. So we have x plus x to the 4 divided by 4 factorial plus x to the 7 divided by 7 factorial, and so on. This keeps going on and on. Yeah, so then that is v. So going back here, this equals to v. Alright, so what I'm gonna do is I'm gonna box this in. So du over dx is equal to w, dw over dx equals to v. And now, so that's v, so let's take the derivative of this one now, and this should be u. So d over, dv over dx, take derivative of this one, is already written down, so we don't need to write it again. That's just going to be 1 plus, this one, the 4 goes down. We have x to the 3 over 4 factorial plus 7x6. And bring that, the 7 down, the power down 1. And then over 7 factorial, then plus dot dot dot. And we keep going on and on. In other words, we get it cancellations. This becomes 1 plus x to the 3 over 3 factorial plus x to the 6. Again, those are factors of 3 now. In other words, we are becoming u. Okay, over 6 factorial, and this plus dot dot dot. This equals to u. And we can see that that is just our starting point. So that's u right here. So we can keep taking derivative and just cycle through them nonstop. So that's there, and just scroll back up. And yeah, just to show. So u is 1 plus x cubed divided by 3 factorial plus x6 divided by 6 factorial, and so on. Alright, so going back here. So u is x3, yeah, so 1 plus x cubed divided by 3 factorial plus x6 divided by 6 factorial, and so on. Thus, put it all together. Thus, we have u prime, or the derivative, is equal to, u prime is equal to w, equals to w, and then v prime, so we have this, and I'll put v prime is equal to, derivative of v prime is equal to u, so this derivative dv over dx, just write it as u prime, v prime, and then finally, w prime is equal to v. So this one is equal to v. So yes, that is what we have. Box this out. Alright, so now let's differentiate the left-hand side of the desired equation, because now we know all the derivatives and so on. So if we go back to the desired equation, we were asked to show Yeah, to show that this right here, u cubed plus v cubed plus w cubed minus 3uvw or 3uwv is equal to, yeah, is equal to 1. Actually, the way it was written, it was better this way, uvw, so that's just better order, uvw and then 3uvw, anyways, equals to 1. So we show that it's equal to 1. So what we'll do is we'll take this and take the derivative and then see what it equals to. So thus we can differentiate each of, actually we have one there. So let's differentiate the left-hand side of the desired equation. So what we'll do is d over dx of u cubed plus v cubed plus w cubed minus 3uv. So 3uv right here. uvw equals to, alright, so this equals to, well, let's take derivatives. The 3 goes down. You get u squared, and then we're going to have to multiply by the, using chain rule again, u prime, the inside. Like that. So that's u prime. And then the next one is same thing, 3v squared v prime, and then plus 3w squared w prime. And now the next one is, well, we need to do this one here. So we're going to just make some room, subtracted by 3. I'll just factor that out. And then we're going to use the product rule. So derivative of uvw is equal to u prime and then vw plus, now derivative of the other one. So this would be uvw, no, v prime times w, and then plus uw, uv. Yeah, so you have to sum up each one derivative separate, then w like that, w prime like that. And I'll just put a sign here. So recall, this is the product rule, like that. Alright, so now let's plug in all of our variables inside. So this whole thing is equal to, I'll make some room here. Actually, we'll have some room here. So so equals to 3u squared times u prime. U prime is w. So we'll have 3u squared w plus, and we can actually, just factor out all that 3's there. So yeah, because there's a bunch of 3's everywhere. So let's take this out. So it's going to be 3, and then put a bracket like this. And yeah, we will get 3u. This is u squared w, so u prime is w. And the next one is plus v squared, and then v prime is u, plus, and then we'll have w squared, and then that's w prime is equal to v. Like that. So that's what we have there. And then minus this setup over here. And yeah, we're going to need some more space here. Alright, move this down here. And this equals to, yeah, so wv, and then we're going to have, we subtracted, yeah, so we factor out the 3 out of there. We're going to have a u prime is w times by v, yeah, vw. So what we have, the w is theirs already, so we'll have a v w squared, and then plus u w, and then v prime is u, so we'll have a u squared w, and then now here u v w prime, w prime is v, so we'll have a v squared there, u v squared, like this. So if you take a look at this, what we can cancel, and this is subtracted by, so we have a u squared w, this cancels with this. We have a v squared u, so this is a v squared, u squared v, that's the same thing, those cancel. And then we have a w squared v, w squared v. So those cancel, and the 3 is, yeah, 3 multiplied by 0. So in other words, all these cancel, this all equals to 0. Like that. Alright, so if it's equal to 0, that means then the integral, if you take the integral of that, basically what it's saying as well, this means that u3 plus v squared, u to the 3 plus v cubed, or v to the 3 plus w cubed minus 3uv, this has to equal to c, which is a constant. So we have to have this. Yeah, we have to have this because the derivative is 0. So the only way, if you take the derivative on the left side, has to equal to the derivative on the right side. In other words, the only way is a constant. So make the constant goes to 0. All right, and to find the value of the constant, we can put x equals 0 into this into the last equation right over here, and get, well, if we look at our UVW, so our u is this, our v is this, or if you scroll all the way back up and look at it, so here's our u, here's our v. So if we put in x in all of them, w is equal to 0, v is equal to 0 because all vanished, and all we're left with is u equals to 1. So which is quite remarkable. So let's go back here. So we get 0 and everything. So what we're going to get is u becomes 1. So we'll have 1 cubed plus 0 is v plus 0 is w. We'll put it, just for completeness, u 0 to the power of 3, and then minus 3 times it by 1 times 0 times 0. So in other words, we get, and this is all equal to c. In other words, all this vanishes but 1. So this is all we get. N equals to 1. So 1 cubed is just 1. Thus, we just solved our the question we were asked, because we had to show that it equals to 1. Thus, u cubed plus v cubed plus w cubed, that's plus w cubed, all right, w cubed minus 3uvw is equal to 1. And there it is. That's what we were asked to solve. And we can see that again. Scroll back up to the question, and there it is.